Increasing, decreasing, stationary points. A function is said to be increasing if the tangent has a positive gradient. That just means it's sloped to the right. A function is said to be decreasing if it has negative gradient. That means slope to the left. A function is said to be stationary if it has gradient 0. That means it is a horizontal line or it's just flat. We agree with that? So increasing, slope to the right, decreasing, slope to the left, stationary, y dash equals 0. Your gradient is 0. So in other words, we've got y dash is greater than 0, y dash greater than 0, y dash less than 0, y dash equals 0. So when is a function increasing? When y dash is greater than 0. Let's just say that one. When is a function decreasing? And then when is a function stationary? Equals 0. Okay. So those are the words that I said you need to know. Those are the first three. So here, on the following graph, indicate where the function is. Increasing, decreasing, stationary. Let's start on the left. It's increasing. One to Greg up there. And then homework, one for each one, please. Increasing, that's 0.
Yeah, 0.
Decreasing.
And then one for everyone.
Increasing. Increasing, 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 actually, all the way up. Isn't it? Can we all see that? That's thank you. Yep. Any questions?
No.
Done. Let's try this one. What do we reckon? Increasing, 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 flat. That's stationary. Decreasing, decreasing. It's still decreasing, 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 decreasing. 0. Increasing, 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 increasing. 0. Decreasing, 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 decreasing. We're happy with that?
There.
When is something decreasing? Example 2. Show that y equals 5x plus 7 is increasing for all values of x. What's the key word there? Increasing. When you see that word, you go y dash greater than 0. Let's start. Y dash equals 5. What do we know about 5? It's always greater than 0. Therefore, increasing. Part B. Show that y equals x cubed is increasing for all values except x equals 0, where it is stationary. Let's see. Y dash equals 3x squared. That is always greater than 0 for any value of x except at x equals 0, which gives what? At x equals 0, what do you get? Y dash equal to 0, which is stationary. I think you guys get it. You're not going to get a question like that in your exam. You will get C. C will be what you will see in your exam. It'll actually just say, for what values of x is this component increasing? All right, so that's f dash of x equals 3x squared minus 6x minus 9. Greater than 0. It's up to you how you guys do these by now. I'm going to divide by 3. and I make it equal to usually, just my way, x plus minus 3 plus 1, right? So I get x equals 3 and x equals -1, and then I usually test. If you do it graphically, you don't need to test, obviously. Test x equals 0, sub it in, I get -9. Is -9 bigger than 0? No. So the answer is x is less than -1. As long as x is less than -1 or greater than 3, this curve will always be increasing. Make sense? All right, I thought it's easy. I might leave this one as classwork or homework, I'll write for now and we'll come back to it. Next, HSC question. Yep, before we do that, let's move to this one. Come up here. All right. How to draw derivative graphs. You would have learnt it from your teachers one way, I'm sure, because I think they do it part of the Year 11 course. But we're going to do it using the ISP method. You guys heard that before from your teachers? I wouldn't think so because I made it up. So, intercept, stationary points, points of inflections. Going down is actually integration. So that's for next year, will help us. Going up is going to be for differentiation. The way we read this is points of inflections become stationary points. Stationary points become intercepts. Now that makes sense so far? Okay. Now we've got this black line, y equals f of x. So this you've got to draw in your books or whatever, just write how to draw derivative graphs. You've got this black line. We'll talk about a point of inflection soon if you're still confused about that, but we've got this black line. Stationary points become intercepts. Well, it's stationary right there. What do I know about an intercept? I know that's specifically on the x-axis, right? Because it's an intercept. And that's great because you know the y value of that. So it's right there. And that's the only thing I have. I don't have a point of inflection on the black curve. I only have one stationary point. So again, points of inflections become stationary, stationary become intercepts, intercepts become, you don't have anything for that. All right, so that doesn't go on to anything else. The only other thing you have is what I taught you with polynomials, which is start from the top left, start at the bottom left. So if the graph starts at the top left, we start at the bottom left. That's why I teach like that, because it's all uniform. So instead of this black line starting up here, we're going to start down here, cut through. And that becomes your derivative graph. Make sense? You guys can do it whatever your teacher's way would be, which I know is if this is decreasing, it's below the x-axis. If it's increasing, it's above. That's just not what I do because it doesn't work very well for hard integral questions and stuff, but whatever. It is what it is. Next one, black. A point of inflection, for those who have never heard of it before, is just where it changes from a maximum to a minimum. So it's just that point there. That's called a point of inflection. So at a point of inflection, we know it becomes stationary. At a stationary point, I know it becomes an intercept. So the first one I start with is the S. I'm going to start with my stationary point. So stationary, stationary. I know it's an intercept right there. I know it's an intercept right there. So done. We're happy with that? Next one, point of inflection. I know it's stationary. I don't know the y value. So I don't know how high or how low to go, but I know it's either going to be sad or it's going to be happy. The only other thing I know is start bottom left, start top left. And obviously you're going to start up here, cut, bounce, cut. Any questions? Let's see. I'll give you guys one to do yourself. So you can try this whole ISP, make sure you get it. Let's do that one. Pretty much an M. Try to draw that. ISP. You're going up for derivatives. It's the opposite of the SC acronym that I did for sine and cos. That one's going down for derivatives, so you can always think it's the opposite. That's what you need to know.
Yeah.
All right. ISP. Let's see. I usually do stationary first. Stationary becomes an intercept, so there, and there. That is a, like that, and that one there, somewhere there is there and there, and that's all I know. The only other thing I know is start top left. So start top left, it's obviously going to meet this guy, going to come up here, it's going to meet this guy, come down, and voila. Easy? Everyone happy? Now we're going to do the hardest one you'll ever see. The hardest one you'll get would be a horizontal point of inflection, which I'll explain in a second what that is, and an asymptote. And you'll see what happens there with asymptotes. A horizontal point of inflection. So that means it's got to be horizontal and a point of inflection. That's your squiggly ones. That is a point of inflection because can you see this was sad, but this was happy. So something in here happened. So that means that there's a point of inflection, but because it's flatter and it's not like these ones, it's not a point of inflection. We call it a horizontal point of inflection. So it's still flat. But y dash still equals to 0 there. At that point, y dash equals to 0 and y double dash equals to 0. And we'll do that in a second. You'll see it. But here's one. Now what I'm going to do is I'm going to get rid of that answer, obviously. Okay. Boom. Horizontal points of inflections. The reason why it's hard, because people don't know this. They become stationary and intercepts. Why? Because I just said it's horizontal, which means it's stationary, and it's a point of inflection, which means it's a point of inflection. So when I differentiate that, the P becomes an S, the S becomes a I. Okay. So horizontal points of inflections, anything you see like this, these squiggly ones, they are stationary and intercepts. So make a note of that, write that down. And if you've got any questions, ask me. What's so special about knowing it's stationary and an intercept? Well, with stationary, look at it. We didn't know the y value. We're just drawing it somewhere random. But with a stationary and intercept, I specifically know it has to be on the x-axis. So it's not anywhere, it's not in midair. It's specifically here. Make sense? The rest is easy. That's a point of inflection. I was hoping to not show you guys that one, but oh well. That's sad and that's happy. But can you see from there, somewhere here, there had to be a point of inflection for this to change from a happy to a sad again? A lot of people missed that one. And then let's continue. Sad, 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 sad. And then something happened here for it to become happy. So actually there's another one here and here as well. That's stationary, so that becomes an intercept. And that's all we've got. Here we go. Start up here. Bounce. But then how am I going to meet this guy? And that's where you realize, oh yeah, there's meant to be a stationary point. So stationary point. Cut through. Still good? Anyone have any questions at this stage? Coming, 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 coming. And then you know there's going to be a stationary point here. So stationary point. And then what? And then what? Think about something. And then what? And then just... And then that? She's saying yes. But it shouldn't be. At -5.
Would it be a 0?
At 0. Well,
Yeah.
pretty down. Oh yeah, that's a good idea. You can think of it like that, but hold on. Yes, but hold on. My only thing I'm going to tell you is, when did we have intercepts? When did we have intercepts? At stationary points, right? There was no stationary points here. So how can you have an intercept? Simple. So you can think of it like that. Like you know you can't cut through because you didn't have it in the first place. Asymptote at 0. And that's it. That's the hardest one you'll get. Even in 3 unit, 4 unit, doesn't matter what it is, that's the hardest you can get. It's the logic of it. Horizontal points of inflection become stationary and intercept. So they can pretty much become stationary on the x-axis. I think that's it. Now we can go back. Any questions, Andy?
No, not at the moment.
All right. All good. All good, all good. Let's do this HSC question. For what values of x is the derivative negative? So when will y dash be less than 0? What does that mean again? Decreasing. So you gotta get all these words. Decreasing. When is it decreasing? There. Increasing. Okay. Someone want to say an answer? And can you say how would I write that? So -1. Yeah. Okay. I just want to make sure you guys are not going to say equal to. It can't equal to x because what? Why? They're stationary points. Good. Okay. Okay. We get that. Double I. What happens to y dash for large values of x? Well, instead of guessing, don't do double I. Do triple I. Sketch the y dash, then you'll know what happens. All right, here we go. Let's draw my little ISP. We're going upwards for derivatives. Stationary becomes intercept. Stationary becomes intercept. Point of inflection somewhere there is going to become stationary. Point of inflection somewhere there becomes stationary. And that's it. Start bottom left, start top left. You guys love that rule, don't you? Go here, go here, go here, go here. And then what? Boom. Asymptote approaching 0. So what happens now for large values of x? F dash x approaches 0. So the y values approaching 0. Easy. Which is what you assumed before, Ben, anyways. You understand the concept of differentiating a constant. Or another way to think about it, I mean, if you really wanted to, the gradient of this is becoming flatter and flatter. As you differentiate that, it's going to just approach literally become 0. So there's two ways of seeing it, but whatever. I think you should know it graphically. Good. So I will never do double I before triple I. I'll always do triple I. Then I'll go back up and fix up my double I. I think I showed that in inverse trig or something. I could really sketch it as well before doing domain and range. Same thing, I think. Whatever. All good. Any questions? Done. Move. 4 marks. HSC, by the way. All right. All right. I think because you guys are fast, I'm going to skip this bit, right? And I'm going to just do the whole thing in one go. I feel like you guys can do it. If you realize it's too fast, then I'll come back. So let's see. Okay, so I'm going to do this. Example 5, page 7. Example 5, page 7. The rest, I reckon you can complete yourself. That's why I'm saying you should do it. This one. Okay. Stationary points and nature. There are two ways of doing nature, and I am going to do both ways. Eventually, you've got to pick one to use more often than the other one. One method is more superior than the other, but it doesn't mean it works all the time. So, you have to actually know both methods. Let's start. Your working out's very important to me. I want it to be set out exactly as I do it. It just looks really nice to an examiner when they're marking it, everything's there. When you're graphing these, you're going to have all these numbers. You don't want to go back and look at where your coordinate is. Do it as I show it, we'll be fine. Let's go. Y dash, stationary points. Okay, here we go. First step, y dash equals 3x squared, take away 3. Second step, y double dash equals 6x. Easy? Easy way to start. Then we write stat points. Stat points. We underline it. We write y dash equals 0. So that way, you'll never forget stationary points is y dash equals 0, and it just looks neat. It shows us that that's where it started. How do we find stationary points? Yeah, y dash equals 0. Okay, y dash equals 0. Here we go. 3x squared, take away 3 equals 0. X equals plus minus 1. I'm just going to do it like this. X equals 1, x equals minus 1. Any questions at this stage? Remember, this is HSC, so this will be in your exam. For those who are doing advanced, 100%. Next week, this will be in their paper. They'll just say find station points of that curve. Nothing harder, nothing easier. That's it. Y equals. What's a very important word from stationary points? You need a point, x and a y. So, sum it back into original. Be careful, there's 3 y values. A lot of people getting confused. Y, y dash, y double dash. Y is y. Y dash is y dash. Y double dash is y double dash. So sum it back into the original. 1 take away 3. Negative 2. Negative 1 plus 3 is 2. If I'm not doing my math wrong. Done. You found your stationary points. 2 marks. Nature. You write nature. You underline it. Now, there are two methods. We're going to do both. We'll do both until you guys realize which one you want. Then I will just do that one, but you'll need both. Nature, method 1. Y- table. Method 1 is the Y- table. Literally, you draw a table. Instead of it being X and Y's, it's going to be X and Y'. At 1, Y' is what? When X is 1. When X is 1, what does Y' equal to? When X is 1, here. No. Good. Yeah, I said that. Y is -2. Y' is 0, right? That's what you just proved, it's stationary. So your middle must always be 0. Again, let me just do the second one. X, Y'. For -1, what does Y' equal to? Also 0. Cool? Then all we're trying to do is find a number before 1 and a number after 1 and show what the gradient of that is. So a number before 1 is 0, number after 1 is 2, before 1 is -2, after 1, -1 is 0. Quick note. Try to be as close as you can to your stationary point. I say that because if this number here was a 0, and if I chose 0 here, you're going to get a wrong answer. It just won't work. So if this was 0, and you chose 0 as 1 before 0, it won't work. So you wanted to choose 0.9 and 1.1. So the logic generally is be as close to your stationary point as possible, because sometimes you might have gone a bit too far. Okay? But for now, it's okay. I'm talking about exponentials, trig. I'm talking about like next year. It's just it's good for you to know. I want to stay as close as I can. Done. Then, what do you think you're going to do? Sub in 0 into Y'. It becomes -3. Sub in 2 into here. 4 times 3 is 12. 12 take away 3. 9. -2, that should be 9. And that 0 should be -3. Okay. And what do we know about Y' being less than 0? What did we say? Y' less than 0 means decreasing, slope to the left, 0, Y' is positive, slope to the right. What does that look like? Min. This one, Y' is 9. 9 is not important. It could have been 900. It doesn't matter. Positive. Positive. 0, negative. Max. Ooh, done. You just found out if it's a minimum point or if it's a maximum turning point. Again, any questions? Easy. That's method 1. You'll need that because method 2 might be hard sometimes. Not this year hard, probably more next year hard. Y" method. I just call it Y" method. For Y", if we have Y" less than 0, I can straight away say it's a max. That's what's good about it. If Y" is greater than 0, I can straight away say it's a min. It's the opposite of what your head might think. For increasing, you would say Y' is greater than 0, which logically makes sense. For minimum, you would have thought it's less than 0, but it's not like that. It's opposite. So maximum is less than 0, minimum is greater than 0. Then all you do, you write at the point 1 and -2. 1, -2. At -1 and 2. What does Y" equal to? Let me scroll out for a bit. Y" was 6x. Y" was 6x. which equals to what at this point? 6. 6 times 1. That makes sense? You sure? Greater than 0, therefore it's a min, which is exactly what we got up here. Less substituting and stuff. So I think you guys know which one I use. -6, less than 0, max. Obviously, y double dash is the more superior one, but as I said, it's not that it doesn't work all the time. Yeah, it also doesn't work all the time actually. There is a flaw in it, unfortunately, but still, it's more that sometimes it's hard to get the second derivative out. It was already hard enough to get your first derivative, let alone the second derivative. You just don't want to do it. It's easy just to substitute in. So you'll realize that as you see a question, you're like, I don't think I want to do this again. Okay. Happy? We now do the stationary points in nature. Sketch the curve. I think that's nothing, right? I'll just do it up here. What do we have? At 1 and -2, 1, -2, and -1 and 2. That's a maximum, that's a minimum. Done. And obviously somewhere in between there would have been a point of inflection, which we're going to prove soon, or find soon. Doesn't matter where you cut at the moment. Where you should cut really actually is 0, 0, because that's your intercept, y-intercept. But otherwise, whatever. All good? How many marks in your exam? How many marks do you think?
3.
How many marks altogether?
2.
You reckon 2 or 3? I wish. 6.
1.
2 marks for the stat points. 2 marks for nature. 2 marks for sketching. 6 marks. And here it is again. Let me just see. Yeah, why not? Do it. Good practice. I'll pause. Go. So, y dash, y double dash, stationary points, nature, whichever method you like. Doing this backwards. That's what I thought. So it's really important on the class. 100% of the exam. I guess I'll just slowly start off. F dash x, 15x to the power 4 minus 60 squared. F double dash x, 60x cubed minus 120x. Stationary points, underline, y dash equals 0. 15x squared, factorize it out, I think. X squared minus 4 I get x equals 0, x equals 2, x equals negative 2. I'm sure you guys will now go and find your y values. Should be able to continue from there.
Sure.
And that gets confusing because in nature, when we do the y dash table, we actually do sub back into the y dash. Because the y dash table, right? Plus this guy divided by 2 gives you this one. Y plus this divided by 2 gives you this one. Because it's short. Yeah. Because eventually you're going to solve. Okay. What are the y values that we got?
0.
Nature. What's my nature? Nature, which one? Do you want to do both methods again? Just to make sure, or y double dash method, we're happy with that? Let's do it. Nature, y double dash. Okay, here we go. So, at 0, 0, y double dash equals 0. I'll come back to that one. At 2 and negative 64, y double dash equals 240, greater than 0, min. At negative 2 and 64, y double dash equals less than 0. If, when you're doing this method, at this stage, you get y double dash equals to 0, the only conclusion you can make is possible point of inflection. That's all you can conclude. Y double dash. Yeah? Just y double dash method. I'm subbing into the y double dash.
I would go way around the table.
Possible point of inflection. Now, this occurred, which is okay. What you would have done, we would have done our next step, which would have been a point of inflection. With our point of inflection, it probably would have worked. Let me see the graph. Yeah, I think it would have worked. but I'll show you what you would have done with your y dash table. So, you're all right. So if this happens at this stage, for now, until we do point inflections, and I'll show you what we're going to do the whole way through. At this stage, we're going to try the y dash table, just because this occurred. But it's good that you know that it's a possible point of inflection. You have to actually conclude that. Possible point of inflection. Then you'll go to step 3, which is point of inflection, but we haven't done step 3 yet. So right now, we'll go to the other method for this. X, y dash, 0, 0. We choose 1 before it, -1, choose 1 after it, 1. Where do I sub it in now? Aya. Where do I sub in -1? See, this one here, y dash. Don't look everywhere, it's right there, y dash. Whereas this was y double dash. This is y dash. So sub in -1 into this guy here. And what does that give me? I think 15 take away 60, -45. If I sub in 1, I think it's still going to give me -45. And what is that? Look at that, that's a negative, 0, and a negative. So that's not minimum and not a maximum, it's a horizontal point of inflection. Exactly. But, like I said, we can't actually conclude that just yet, because we haven't done step 3. But like, we're just going to assume that for now, but not allowed. Okay, let's get that clear. So even if you did that, you're not allowed to say it's a horizontal point of inflection. So let's make that clear. If you ever get this -0, negative, you're not allowed to say it's a horizontal point of inflection, because you have to prove it's a point of inflection. So, yeah, so just be careful. We haven't done step 3, but we'll be doing step 3 shortly. Graph, sketch the curve. Here it is. 2, -64, -2, +64, and at 0, 0. All right, easy. Right, horizontal point of inflection. That's sad, that's happy. When we're done. What about the time? Good. Question? Next one. Second derivative. I don't think we need to do second derivative because you guys have already done all that. All right. We just spoke about it, but I'll say it again. Y double dash, if it's greater than 0, it's a minimum. Y double dash less than 0, it's a maximum. Y double dash equals to 0, the nature of the point is inconclusive. In this instance, we have to check on either side, determine its nature, and you'll see that in a second. Find any turning points, determine the nature, that can all be done. Anything I'm leaving, classwork, homework, whatever, but I'll write that in a second. Finding points of inflections, determine the points of inflections, I think we already get that. Let's just jump into it. Let's do example 12. Find all critical points. What are all the critical points? X and Y intercepts, stationary points, and points of inflections. So let's, pretty much, right? ISP, there you go, I never thought of that. All right, intercepts. Intercepts. When x equals 0, when x equals 0, you're going to get y equals 0. When y equals 0, we get x squared plus 6x plus 9 equals 0. You should already know you have to factorize. How could this be tested in 3-unit? Polynomials, I guess. So there will be a plus 5 there at the end of it, and then you have to actually look for your root to be able to solve, because you can't solve in any other ways. In advanced, they can't give that constant term, so they can factorize, and now it's just a quadratic. Cool? Just so you know the difference between the two. Otherwise, everything else stays the same. X equals 0. I think that's a perfect square. So x equals negative 3. That's it. Those are your intercepts. Done. Done. All right. Stationary points. Stat points. Underline. Y dash equals 0. I guess I could have underlined that as well. Y dash. Y dash is 3x squared plus 12x plus 9. 3x squared plus 12x plus 9. I can see I can divide everything by 3, so I'm just going to do that again. And I think I can see my factors 3 and 1. So x equals negative 3 and negative 1. Underneath it, I usually write y equals. Where do we sub it in? Original. Negative 3 cubed plus 6 negative 3 squared plus 9 negative 3 is 0. Oh, there you go. So it's stationary and it's an intercept. Cool. Which I think you guys understand what that's doing. Right? Just bouncing on the. If it bounces, which we understand. If it bounces, we understand that this must have been this. We realize that up here anyway. So it's got a root of multiplicity of 2. Okay? It's all coming together now. Why negative 1? Negative 1 plus 6 negative 9 is negative 4. You're done. We get to nature of this. Nature. I usually do the y double dash method. So we write at negative 3 and 0, y double dash equals 6x plus 12. 6x plus 12, which equals negative 18 plus 12, negative 6, less than 0. Y double dash equals 6x plus 12, at negative 1 and negative 4. You're obviously not substituting y's ever, right? We're just writing it because we're saying at this point. Negative 6 plus 12 is 6. Is 6 greater than 0, which is a minimum? All good so far?
Yep.
And last one, POI. When does a point of inflection occur? Yep, so when algebraically, y. So stationary points was y dash equals to 0. We realized when we're trying to do nature, if y double dash was less than 0, it's a maximum. When y double dash was greater than 0, there was a minimum. What needed to happen right there? Y double dash needs to equal to 0. Simple? I think so too. Y double dash is equal to 6x plus 12. So 6x plus 12 equals 0, which means x equals negative 2. What do I have to do now? Sub back into the original to get a point. It's called a point of inflection. Y equals. Okay, back to the original. Negative 2 cubed. Ugh, it's just easy to just minus 2 plus 24 minus 18. Negative 2. Negative 2, negative 2. All right. This is where I've always had one student every year, unfortunately, lose a mark. Even if the question asks you to find points of inflection, don't stop at just finding point of inflection. You must prove it's a point of inflection. Just remember that. Make a note of it, whatever you've got to do. We must prove it. Must prove. With points of inflections. Cool? Even if it was worth 1 mark, and you thought, oh, but it's done, Sam, I just did it. X equals -2, done. Too bad, you get 0. You must prove it's a point of inflection. How do we prove it? Y double dash table. Starting to see a pattern yet? X, Y double dash. Y double dash table. Order doesn't matter. So it's not like your other one where it mattered if it was slope to the left and then slope to the right or right to the left. Order doesn't matter. We just want to see a change. If there's a change, that means moving from a minimum to a maximum, or a maximum to a minimum, which means there must have been a point of inflection in between. So X is -2. We choose a number before it. Yeah, I guess it does. Look, I won't choose it just to make a point. If I chose -3 and -1, they were my stationary points. Let's not choose them. It might complicate things. You might have been a stationary point and a horizontal point of inflection, which means this would have disproved. You just stuffed up. So if it's a point you've used, don't use that point in your X's here. So we're going to choose -2.1 and -1.9, I guess. I think we can use -2.5 even. I'm just going to choose that. But whatever. Doesn't matter even if you wrote whatever you wrote. It doesn't really matter. Trust me. We're going to conclude the same thing. Y double dash is obviously equal to 0. I did say that. The middle has to always be 0. -2.5. Sub it into what? Oh yeah. Y double dash. That makes sense. Plus 12 gives you -3. At 1.5, it gives you 3. Great. What does that mean again? What does y double dash less than 0 mean? Maximum. What does it mean equals to 0? Equals 0. Y double dash equals 0. Point of inflection greater than 0. You know. So therefore, conclusion you have to make is, since change in concavity, since there's a change in concavity, -2 is a point of inflection. So that's why in nature, whenever you get 0 up here, we can only conclude it's possible. Because we have to go onto here, do the math, and then to prove it. Because what if it didn't work out? Then it's not a horizontal point of inflection, it's probably just a stationary point that's quickly bouncing somewhere or doing whatever it's got to do. So be careful with those. All good, move on. Any questions? That one, that's actually, if it was including the graphing, I think they get to about 10. So that's 10 marks, obviously. 2 for the intercepts, 2 for stationary, 2 for nature, 2 for inflection, 2 for graphs. What is it?
Imagine it's like a graph page.
Yep, 10% gone. But that's really, these ones are like band 2 questions. They don't get hard, so they're meant to be for the whole state. They're really easy. Everyone goes in, just gets solid marks. Find any points of inflections. I'll leave that for you guys. Think. That one we will do. For what values of x is a concave up? What's the key word? What do you know about that? Keep going. Something like this, that's what I want to hear. But not, it hasn't said it. Gradient, y dash gradient 0 means what? Increasing, so don't mix the things up. Concave up, y double dash less than 0. True? Because it's a minimum. No, what? Whoa. Ah! Greater than 0. Minimum. Oof. Concave up. Y double dash greater than 0. Bless you. It's concave up. It looks like this. It's a minimum point. That's what I want to hear when I say concave up. Not so much that it's a minimum, it's more that y double dash less than 0, y double dash greater than 0. What's the point of inflection? Y double dash equals 0, stationary point, blah, blah, blah. You need to know it like that. All right, all good. For what values? Let's go. Y dash equals 9x squared minus 8x plus 5. Y double dash equals 18x minus 8. Make it greater than 0. I think we can all see, as long as x is, without it being simplified, greater than 8 over 18, the graph will always be concave up. Just from that, obviously, when is it not concave up nor concave down? No. Say again? Yeah, which means when x is equal to 8 over 18.
Oh, yeah.
True? Because you just did it for greater than 0, equal to 0 is the same number. All good. Done. Easy. And that's a little summary. But before we do the summary, I'd rather you guys try this. Now, before you do it, because the class before you failed, listen, don't overthink it. Just relax. It's simple. But what you do need to know, I'll start with 1, for example. What you do need to know is this one here. What does that mean when it says y dash equals 0? So you write it, SP. What does it mean when it says y dash less than 0? Write it. So now you're looking for, mark a point A, where it's a maximum stationary point. Man, it's right there. Right? Simple. But you need to be able to interpret that jargon to those little SP, max, whatever, increasing, decreasing. Okay, I'll leave it with you for just 2 minutes. Do whatever questions you can do. You'll be surprised. Exam technique. You can't do I straight away, move on to double I. You can't do it, move on. Move on. If mine is not coming to you, is it coming to you at all? If not, move on. What does double I say? Solve for f of x greater than 0. You know when f of x is greater than 0. Again, if it's coming to you, great. If it's not, move on to the next one. Exam technique, literally, if it takes more than 2 seconds. If it doesn't come to you, move on. Oh, if you can, why not? I feel bad for you. You had 17 marks of terms. Did you know that in your exam? 17 marks.
Ours was 10.
Oh.
And well, like basically pretty much everyone were like 10 of them.
Yeah.
It was so
That's so weird. Why would they even do that?
They make both massive exams harder than usually teachers are saying.
Seven- 17 out of 50, that's okay, nearly, no, more.
Oh, is that 50?
Yeah.
Yeah, I was at 120, that's.
Oh, okay.
120.
Well, it's a lot.
Oh.
How long was it good?
2 hours.
Yeah.
Yeah.
I was just,
All right, let's do it. Anyone get I? Evaluate f of 0. Y-intercept, right? It's just when x equals 0, the answer is just 6. Yep. F of 0. What about when solve f of x is greater than 0? When is the whole graph above the x-axis? Yep. X is less than 10. Negative infinity to 10, whatever. Makes a whole lot of sense when I write the answers now, doesn't it? That's what I'm trying to think for yourself. You're going to be like, come on, it does make sense. Mark a point B on the curve where these two have opposite signs. It doesn't matter. It's just saying as long as they have opposite, it doesn't matter what they are, just opposite. So that means pick. What do you want for the first one? Positive or negative? Pick. Positive, that means the next one must be? What does it mean if y dash is positive? Increasing. You're still mixing the stuff up. Where is y double dash less than 0? Negative. Less than 0 means max. So you want a maximum curve where it's increasing. Maximum curves look like this. True? When is a maximum curve increasing? Well, this component here. So, looks like that bit there. That looks like it's increasing. And it's a maximum. This bit here is a minimum, by the way. Can you see it? And that looks like a point of inflection somewhere there. Point of inflection. All right. C is a point on the curve where the concavity changes from concave down to concave up. Mark the point C. All right, from down to up. This is from up, concave up, to down. Yeah, that's a point of inflection there. But that is up to down. We want down to up. Down, can you see that's concave down? And then that's concave up. It's right there. That's C. Does that make sense? This was in an exam, by the way, as you can see, worth 6 marks. Which of the following is true of C? Obviously, I think Rosemary just said it. It's a point of inflection. It's where y double dash equals to 0. It's where it's changing from concave down to concave up. That's just a point of inflection. I think this is the integral graph, so that is next week. That one's not for you. That's for me to do next week, October 22nd. Okay. That one you can do. Example 17. No cold or okay? Good. Again, write the things down. I answer y dash equals 0. What are you going to write? Y dash equals 0. So write SP. What about when y double dash is less than 0? What do you know? Now that you know it, you're looking for a maximum stationary point, which is what letter? See? Otherwise, I saw you, you're just looking at it and it just looks gibberish. You're meant to actually interpret it. Do it like that. That's it. Is y dash less than 0? It is decreasing. Above the x, above the x equals to y squared is 0.
But on.
Increasing, yes, exactly. Stop right there. This is just close, and it's a point inflation. Pure. Point inflation. Good. Now have fun. What is this? It's interesting. No, I didn't say it's wrong. It's just, you guys didn't get that one wrong. You got it right. Unless.
Okay.
Get it wrong. And that's why I'm saying try to write things down. All right, double I. Double I. Y dash is equal to 0. That means stationary point. Y double dash equals to 0 as well. Point of inflection. That means it must be a horizontal point of inflection. So a horizontal point of inflection occurs when Y dash and Y double dash equals to 0, which is E. E. E is a horizontal point of inflection. Yep. Triple I. Y dash less than 0. Y dash less than 0 means decreasing. Y double dash greater than 0 means minimum. Okay, so it's got to be a minimum, but it's also going to be decreasing. It isn't A. It is D, because that's part of a minimum. Can we see it? And it's still decreasing. The problem is that A you went for, it is a minimum, but it's not decreasing there. What is it specifically? It's that point. And then IV. When is Y dash greater than 0? Increasing, and this means the function is positive. So when is it greater than 0 and the function positive? The only other letter left, which will be B. All good? Write down the set of values for which this is an increasing function. All right, when is it increasing? That's decreasing, 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 0, -2 to 3. I'm pretty happy. Let me just make sure. Yep, I'm happy with that. Everyone's happy with that? -2 to 3. For what values of x is the curve concave up? When is the curve concave up? From? Well, anything less than 2/3, right? So it's concave up, all of this, firstly, which is -∞ to 2/3. Not including, because it's point of inflection there. So it's not a concave up at that point. It's just concave up before that point. You missed it. And it's also concave up here. Can you see it? Because didn't we just do that for when we did D? We said it's a minimum as well. So it's also concave up there. So comma between 5 and 8.
No, come on,
No. No, it's okay. All right. We are done, aren't we? So we can just do, let's say HSC, yeah, take 10 marks. 6, 7, 10. I guess we might as well just do that. Let me just see anything else left. Max mean problems, which is next week. How far in are we? We've done well. I thought it would take 2 hours, but I'm happy. We're going to do both example 20, this one and the next one. This and the next question. Go. We're done. I'll stop the recording because I don't think you guys need it.